today's session, we will discuss about what is infrastructure as a code, what are its benefits, and we will take deep dive into Terraform. But before I start, let me first introduce myself. I'm Sneha, and I have 9 years of experience in IT, and currently I'm working as a senior DevOps engineer at Nuri. Here I'm responsible for managing all the infrastructure using Terraform and also designing and maintaining the CI/CD pipelines using Jenkins and Buildkite. So let's first discuss what is infrastructure as a code. So infrastructure as a code automates the provisioning of infrastructure, enabling your organization to develop, deploy, and scale cloud applications with greater speed, less risk, and reduced cost. The concept of infrastructure as a code is similar to a programming scripts, which are used to automate the IT infrastructure or processes wherein you don't have to manually configure any services. Then what is the benefit of using IAC and why do we need IAC? First is speed. Infrastructure can accelerate every phase of SDLC, wherein you can deploy your changes, test it, and configure it in a way you want. So you can create your production-like environments in no time, giving developers the time to test their changes effectively and efficiently. It also improves consistency. It helps eliminate configuration drift that occurs when you make any ad hoc changes to the environments. Third case, and which is the most important, is auditing. You always need a way to easily review the infrastructure, how it is going to be deployed, and how the services will work once they are deployed. So using IAC, you can mitigate many security and tech risk so that it will enhance your auditing processes. You can also deploy and deliver scalable and stable environments. Since infrastructure as a code is repeatable, so you don't have to do any manual changes on the system, and thus there will be less configuration drift and because of the missing dependencies. You are also accountable for the changes you do on your infrastructure, and you have the ability to see what all changes will be applied, since infrastructure as a code is stored just like any other software code in a source code file. So you have the full traceability of the changes that configuration has suffered. What are the top infrastructure as a code tools which you can use? First is AWS CloudFormation. AWS CloudFormation is a tool which is provided by AWS, and the only thing is that it is based on serverless, and also you can use this tool to deploy infrastructure only on AWS environment. Google Cloud Deployment Manager is a similar tool, but this also can be used to deploy only on Google Cloud, not on any other cloud. Puppet, Chef, and Ansible are few of the configuration management tool that helps you automate the task you want your system to be in the desired state. For example, you have to install and configure Nginx on, let's say, 10 servers. So you don't have to manually log into that servers and install Nginx and configure it, because it's really time consuming, and there are chances that there will be differences between the configuration of the first server and the configuration of the 10th server. In order to keep the configuration and the deployment process almost same, what you can do is you can use one of these configuration management tool. Lastly, and the most widely used, is Terraform by HashiCorp. It is provided by HashiCorp and is widely used to deploy infrastructure on various cloud providers like GCP, Azure, VMware, and whatnot. Now, let's see some of the basic differences between the most widely open source tools. So Terraform and Ansible, both are open source tools, but they are different in the way they are used. So Terraform is a provisioning tool. It can be used to configure servers, network devices, etc. Whereas Ansible is a configuration management tool, which is used to configure any additional software which is required to run a particular application. Note, when you use Ansible, the server or any network devices has to be pre-existing. You cannot build and deploy a server using Ansible. For that, you have to use Terraform or AWS CloudFormation or Google Cloud Deployment Manager. Terraform supports immutable infrastructure, which means that once you have deployed your infrastructure, you cannot change it. It will, if you want to make any configuration changes, it will be first deleted and then recreated again. Ansible is supports mutable infrastructure, wherein, let's say you have deployed Nginx using Ansible and you want to make any configuration changes. So Ansible will make that configuration changes without destroying the existing or underlying infrastructure. Terraform supports declarative language, which means that you don't have to mention these steps. You just have to mention the desired state which you want, and Terraform will do the rest for you. Whereas Ansible is a procedural language in which you have to define the whole process, and also you have to mention the exact uh, steps on how you want to configure that particular service or how you want to deploy that particular software. Terraform is dependent on state and lifecycle management, whereas Ansible does not depends on any state or lifecycle management. These are the basic differences between Terraform and Ansible, and you can use them depending on your specific use case. Now let's discuss the difference between the open source tool, which is Terraform, and CloudFormation. CloudFormation is widely used, but only in terms of AWS. So when you want to deploy any service using any service on AWS, you can use CloudFormation. Terraform is provided by HashiCorp, and thus it supports 24/7 support, whereas for CloudFormation, you have to buy an appropriate AWS support plan. State management in Terraform is Terraform stores the state over your disk, or it can also be used to store your state in a remote backend. CloudFormation stores and manages the state with the use of stacks. Then to make any changes or to see what all changes will be done to your infrastructure, Terraform uses plan command, which will tell you what all changes will be done, whereas CloudFormation make use of change set to verify the changes. Now that we have discussed what is infrastructure as a code, what are its benefits, and noted down few of the differences between the most widely used tools, let's take a deep dive into Terraform. Terraform is a provisioning declarative tool for building, changing, and versioning infrastructure safely and efficiently. It is an open source tool which is provided by HashiCorp, and you can use its HashiCorp configuration language to write your code, and also, if not, then you can also express your configuration files in JSON. Let's discuss what are the main components of Terraform. First come the Terraform core. Terraform core is a compiled binary which is written in Go, and it is the entry point of Terraform. So any one of you, if you want to use Terraform, you have to first download the Terraform CLI from this link, which is GitHub HashiCorp Terraform. Then comes plugin. What are these Terraform plugins? Terraform plugins are also binaries which are written in Go, and these are invoked by Terraform core through a remote procedural call. Terraform plugins are further divided into two parts. First is the provisioner and second is the providers. What are provisioners? Provisioners, these execute commands or scripts on specific resources after their creation or after they are destroyed. Whereas providers basically refer to a particular cloud provider which you want to manage using Terraform. So providers initializes any library or any other dependencies which are required to make the API call to the cloud provider. These are the few of the major cloud provider which you can configure or on which you can deploy your resources. But in general, Terraform supports more than 125 plus providers, and it's not just these cloud providers. You can also use Terraform to create pipelines or configure your Jenkins server or Jenkins pipelines, or you can also use Terraform to configure your GitHub server. So it is very widely used in terms of infrastructure. We already spoke about state file and backends. Now let's see how does Terraform stores the state. First, what is state? So Terraform uses state to map the real world objects to your configuration and also to improve performance for large infrastructure. Terraform state by default, it stores the state in a local file, which is terraform.tf state, but you can also store your state remotely, which is highly recommended. So let's say if you are a team of 4, it is almost difficult to manage the state if everyone has their own local state, because it will be really tough to manage your production environment. So in order to avoid those conditions, it is always recommended to store the state in a remote backend. So backend provides you with many benefits. Few of them are locking, so you can lock your state so that you cannot run Terraform apply in parallel. I mean, you cannot run 2 applies in parallel, so it has to be run in series. It also provides you with encryption at rest, so that if anyone gets your state file, they cannot view what all infrastructure you have deployed. And third one is versioning. You can also always look down a previous version of the file and see and make changes accordingly. To configure a Terraform backend on AWS S3, you have to configure this block of code, wherein you have to define a Terraform block and you have to specify a backend config, which will refer to Amazon S3 bucket. These are some of the widely used remote backend. First is Terraform S3, Azure Blob, or there is one official backend provided by HashiCorp, which is Terraform Enterprise, and Google Cloud Storage. These are the basic resources which you need to run your Terraform configuration. So first you need to specify provider, which will specify on which cloud platform you want to deploy the resources. So this will come under the provider block. Then once you have created your providers, you have to define your resources. What are resources? Resources are basically the building block of Terraform. So they define what all resources you want to deploy. And so let's say you want to deploy an AWS instance. So you will first have to mention the resource and then the type of resource which you want to deploy, and then you can give any local name to your resource. There are many input parameters which have to be passed to the resources, and those you can find in the official Terraform documentation. Then if in order to use this configuration for multiple environments, what you can do is you can also configure input variables. So what does input variable help us? So they let you customize the aspects of your Terraform configuration without modifying the source code, thus making the modules or your code easily reusable. After you have applied your Terraform changes, you can also tell Terraform to store few of the values as output. So you can always specify those outputs in output block. Once you have defined all your configurations, you can then convert these configurations into modules. Let's see first what are modules. So module is a container for multiple resources. They can be used to create lightweight abstractions of your code, in which will help you to describe your infrastructure in Terraform in terms of architecture, but not in terms of physical objects. Let's consider that you have an RDS instance which is connected to an ECS cluster and which is running behind an ALB load balancer. And you want to deploy this whole infrastructure in AWS, and wherein you have to build two environments. First is the production, second is the development. So in order to convert the previous written configuration file, what you can do is you can create modules. So you can create separate VPC modules, separate RDS and ECS modules, and then you can call these modules based on different input parameters. Thus, it helps. I mean, in this way, you don't have to modify the source code again and again. You just need to update the input variables which you want to pass to production and separate input variables which you want to pass to your development environments. This is the basic workflow. So let's say you have written all your configuration files, you have created a separate repo for your modules. Then now what? After you have done all these changes and also you have configured your S3 backend, what you can do is you have to run Terraform init. Terraform init will download the provisioners for you. It will also initialize your backend, plus it will also download your modules from the source code repository. Once the Terraform init is executed successfully, you have to run Terraform plan. Terraform plan will basically take a look at your S3 remote backend file or the remote file, and then it will compare your state file with your latest config files, and then it will show you the differences, in which it will show you what all resources will be updated, what will be created, destroyed and created again, and what will be destroyed. Once you have executed your Terraform plan and you are happy with the changes, then you need to run Terraform apply. Terraform apply will just basically deploy your or your changes as per the Terraform plan commands. And if you want to destroy all of the resources, you could use Terraform destroy. Now, as discussed that you can always use continuous delivery when you are using Terraform. So let's say you have you have a team of 10 people, and you don't want the production changes to be deployed from your local machines through any developer. So what you can do is you can create a Jenkins pipeline. You can configure your pipeline to download the code from your modules repository and also from your repo where you have stored your source code. So once you execute the pipeline, Jenkins server will run all the commands like the init, plan, and apply, and you don't have to run your Terraform changes from your local machine. And it's always a best practice. So before you deploy to production, you always have a check wherein you see the plan file. If it works, then only you will proceed with apply. So before the apply stage, you can always configure a check here, and this will help you to always follow the process of continuous delivery and continuous deployment without the need of running these changes from your local machine. Now let's discuss few of the tips. So so nowadays people are migrating towards the cloud, and if there are many systems which are running under legacy systems on hardware machines. But if you want to automate, let's first try to automate the most repetitive task in ops, so that it will save your time and you don't have to configure or do that task again and again manually. Do not overload modules. So whenever you run Terraform init, the Terraform module repository is being cloned. So Terraform clones everything. So keep the modules specific to the features which you need. Do not hard code any values. Use SSM in AWS or similar services for other cloud providers. Also, try to automate the existing infrastructure in small iterations, because then it will be easier for you to keep track of the changes and to basically deploy or automate the infrastructure deployments. That's it. Thank you for listening.
Thank you, Sneha. It's
Thank you.
bizarre not being able to see people's faces, isn't it, as you're sort of presenting, but at the end we'll do the sort of panel discussion. But no, that was really insightful. Thank you, especially I didn't know being able to lock your state obviously being shared is essential, isn't it? So just to remind everyone, if you keep putting your questions throughout in the Q&A, it does take a while to get going, but any questions at all throughout, pop them in. I just had a question from my side, Sneha, obviously playing devil's advocate here slightly, but you use Terraform as you mentioned at Nuri. If you were to start again or to you know, take it back to sort of scratch, would you still use Terraform knowing what you know? Is there anything else that you would use, do you think?
No, I would still use Terraform because there are many tools. So if you have a dependency module, like if you want to deploy one module and you have to deploy some other module depending on the output of the first module, there are many tools which you can use like TerraGrant or Atlantis. Atlantis help you to plan and apply your resources automatically with GitHub integration. So Terraform is really cool. And now that it is widely used, there are many plugins which you can use to already enhance your infrastructure deployment.
And we have one question from our audience so far. So this is from Gracie Lee. What other benefits are there to using Terraform? Is it good for companies of any size?
Yes, I mean, I have worked in, I mean, previous to Nuri, I have worked in HSBC, which was a very big organization. So there also we used Terraform, and now that I have joined Nuri, here also we use Terraform. So Terraform can be used in any company size, be it a small scaled company or a bigger one.
If upskilling in Terraform, what resources would you recommend?
Terraform official website is pretty much sufficient if you want to learn Terraform. And there are many courses which are available on Udemy. Those are also really helpful.
Perfect, perfect. Understood.